Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, welcome everyone to this 3/4 day worth of machine learning workshop. We have with us today Olivier Grizel from INRIA in Paris. It is in Paris, right?
Yeah, almost.
From very close to Paris. He works on the scikit-learn project, which is a great toolkit for doing machine learning and other processes like that in Python. It builds on top of numpy and scipy. Olivier's work is making that toolkit much better. He's a developer, he's an engineer working on researchy projects, making them great for us. And so he's going to walk us through using scikit-learn to do machine learning in Python. Thanks, Olivier.
Thank you very much. So by now, you should all have downloaded or got fetched two files. One is the parallel ML tutorial zip file, and the other one is the Anaconda distribution for your platform. So you need to install Anaconda on your platform. Hopefully everybody has it running. And then you need to unzip the tutorial material from today in the documents IPython notebooks folder after having installed Anaconda under Windows. If you're on a Mac, you can just unzip the zip file anywhere, and you need to open a terminal, cd into that folder, and run the command IPython notebook from there. All right, so we can switch to my screen. So using Anaconda, you should be able to start an IPython notebook. And if you have unzipped the folder correctly in the right location, you should see this folder, parallel ML tutorial, and maybe additional notebooks that we won't need today. It was, yeah. And mine is this one? Source 2. Okay. All right. Do you all have this IPython notebook list with the parallel ML tutorial folder there? If you have, you should click on it. You should see that content. And so basically, this is a GitHub repo. It's on my GitHub account, Grizel. So later, if you want to fetch it from the public location, you can go to GitHub and clone it. So in the meantime, we will have to go into that notebooks folder here, parallel ML tutorial / notebooks. And we should get the list of notebooks that we're going to use today. Okay. Does anybody of you have a problem? Yes? Yes, from Anaconda, you should launch IPython notebook. I'm sorry, I don't have the Windows UI, so I cannot show you the Anaconda UI.
So if you're on Windows, if you're going to just type IPython.
So in the start screen, you should type IPython, and it will find it. Okay? Does anybody still have a problem to get there? Do you need more time? More time? Okay. Yes. What? You need to unzip the parallel ML tutorial zip file in the document / IPython notebooks. And they should show up in that list. right? Yes. Yes. So when you unzip the parallel ML tutorial zip file, you should unzip it into your documents / IPython notebooks folder. You have your documents folder in your user account on Windows. Then if you installed Anaconda, you should have IPython notebooks folder under that documents folder. And you should unzip the file that I gave you into that IPython notebooks folder. And then when you run IPython, you should be able to see the parallel ML tutorial folder like this.
So how close are we to being ready? Who's got IPython up with the notebooks we need for today?
Right.
Who's still having trouble? Just copying?
So if you still have problems, Steve is around to help you individually. And I will start with the first notebook. So when you have IPython notebook started, you should have in the notebooks folder the list of the material that we're going to use today. So the outline for this first session is going to check that everything is installed correctly. Then we will have a first introduction to machine learning concepts and how they relate to scikit-learn. Then we will show how we manipulate data in a suitable representation for machine learning, especially using numpy arrays. And then we'll explore some basic principle of machine learning. So in the next session, we will cover dealing with heterogeneous data using pandas. In the afternoon, we'll cover notebooks, model selection and assessment, and text feature extraction and classification and clustering. All right, so let's get started with the first notebook 00 tutorial setup. So I will hide this to get some more space. Okay. So when you have a notebook, you can execute cells by clicking Shift-Enter. If you hold the Shift key pressed, it will execute the current cell. So you can see the outline, the focus around the current cell. If you click Shift-Enter, it will execute the cell. So I executed the title, and it doesn't do anything. It just moved the focus down. And if I click if I hold Shift-Enter again, you can see that this time it imported numpy. And I have in this line a different prompt identifier because it has been executed for the first time. If I do it again here a couple of times, you can see 1, 2, 3, 4, because it's executing them one after the other, and I see the order of execution this way. It's possible to go back to the first one and re-execute with Shift-Enter again, and you can see that now I get 5. Yeah? Okay, so if this is weird, it's part of Anaconda usually. Okay, so this is not a big deal. You should be able. What? Yeah, but it should be installed by default on the two of them. So we will install it anyway. So listen for me. So we will insert a new cell. Insert cell above, you see. And here you can type exclamation mark, conda install scikit-learn, like this. And then you execute that cell with Shift-Enter. this is just for people who have not scikit-learn installed. I don't want to do it because I don't want to break my installation because I'm not using Anaconda myself here. But that should fix it for you. It's downloading scikit-learn. It's a couple of megabytes. That shouldn't take such a long time. So if you have scikit-learn, if you can import scikit-learn, sklearn here, there is no need to type this command. It's only if you have a failed import at that line. You don't execute this command if this line works. If this does not raise an error, you don't need to execute this because otherwise you will just waste the bandwidth for people who actually need it. So you can interrupt you can interrupt the running command by clicking on this. Stop here. Here. If you don't need it, you can interrupt the command. So, okay, so the command that I've just typed here is not good actually because so if you type this command, actually it was expecting you to confirm in the background, but you didn't see the feedback. So either you run this command from the Anaconda command prompt outside of the notebook, or you can restart the notebook by clicking here. This will kill the current Python process and restart it from scratch. And then you can execute this command again. Okay? So you have to explicitly mention --yes to install. Otherwise, it will ask confirmation, but you wouldn't see that prompt, and because we are running inside the notebook, and it's not really meant for that. So when we type in ! something in the notebooks, it means that it's using the command prompt under the hood to do some command, like the Windows PowerShell command. Depending on how you started the notebook. Yes. So don't execute further than this because there is another problem. Okay, so has everybody been able to execute those? Yes? If you don't, please raise your hand. Yes. When you start IPython? You need to start the IPython notebook from the start menu. If you have installed Anaconda, so Steve, we're gonna help you. Other people will don't execute further because you will have another error next. Just keep from that. All right. Okay. Does anybody need help? Yes? I'm coming. So apparently the instructions, what I suggested here, sometimes it doesn't work because it detects that numpy is already installed and the notebook is running. And so it's a bad idea to do that. So
just wave your hand and I'll come help you if that's,
yeah.
Try that command and it's stuck. Let me know and I'll fix it for you.
So the alternative way to do that is to run Anaconda command prompt. So you need to go to the Start menu on Windows, run Anaconda command prompt, and in that prompt, you type that. It shouldn't matter. So we'll see next. Okay, so if you are able to execute all of those statements, then that should be great. And we can move on. So to check which numpy and where it was installed, you can, once you have imported numpy, you should be able to execute those two statements. So the first one, path, will show on the file system where is the numpy package installed. So typically here I'm running in a virtual environment which is different from Anaconda. So you can see that it's a VM and it's Python 3.4 on my Mac. But in your case, you should see the Anaconda folder. And then you can check the version number. If it's not the same version, it's not a big deal. Did you do anything? Okay. All right. Okay, and then so you should be able to introspect which packages are installed and where they are installed. And in your case, it should be Anaconda because we installed everything from Anaconda. All right? So next, you can run this script. Maybe you need quotes around the path. But if you unzip the zip file that I gave you, the data set should have already been downloaded. So you can put quotation marks around the path. So the %run and then a path means that it's going to execute a Python script as a cell. So it's a non-conventional way to execute Python in IPython notebook cells. So this is why there is this % at the beginning, because it means that the command that is after this % is a magic command. It's not a regular Python command. So we will see there are different magic commands that are available in IPython. So this is just to check that you have the data. You should see success. Then you can check manually by also putting some quotation marks around the path. Maybe, yeah, remove the, because there is specific, that should work even on Windows, because IPython is doing something magic here. So you just put quotation marks.
Now it's not recognized, right? Yeah, I think you do need to do it. Doesn't do its magic for us. Magic doesn't work. Yeah.
Okay.
There's no glass. This one?
What? Yeah. Yeah, it doesn't work on my side. So you can use exclamation mark there, and then you need quotation marks around the path. It's just a detail, because if the script ran fine previously, the data set should be there. Apparently, ls does work sometimes, depending on the Windows version. Yeah?
Remove the bag and works.
Yeah. Also, if you started IPython from the PowerShell, it might have worked, but Anaconda apparently doesn't do that.
But does it weird error? It doesn't actually do it now.
Anyway. So this is just a detail. If that doesn't work, it's not very important. So let's move on. Oops, sorry, I did. Okay. To a short introduction to NumPy. So how many people in the room were not present at yesterday's session on. Okay, so there are a couple of newcomers. So it's good to have an overview of NumPy. So NumPy means numeric Python. It's basically a Python package to extend the Python programming language with additional data structures, and in particular, what we call a NumPy array. A NumPy array is a chunk of memory where we can put data. And this data can be either numbers, like floats, or integers. Those are numbers too. Or more weird stuff like bytes or whatever. But it's mostly about floating point numbers and integers. So to create a NumPy array, we need to import NumPy. And here we see that we alias the NumPy package as np. It's a standard convention in the SciPy community. So I will encourage you to follow that convention to feel at home when you read other people's code. So we can create a first array by calling numpy np.array and passing a Python list of 3 elements, 1, 2, 3. So we assign that in the a variable. And if we just type a in a new cell, oops, sorry, ignore that. If you type a in a new cell, you should see in the out cell the string representation of that array. So we can do that again for b, but this time we have nested lists. You see that there are angle brackets open twice here. And so basically what it does, it creates a 2-dimensional NumPy arrays, because you have 2 rows and 3 columns. In that case, it's for the a variable, it's a 1-dimensional NumPy array. It only has 3 elements. So we can check the dimensionality of an array by having a look at the shape attribute of the array. So here you can see 2 rows, 3 columns. We can check the data type of the arrays, and we see that in that case it's integer 64-bit integer. Yes? Okay, so some of you are running Windows 32 bits, so you should get 32-bit integer. You're running the 32-bit version of Python on 64-bit Windows if you install the 32-bit version of Anaconda.
Even if you install the 64-bit of Anaconda, it still fails.
This is weird. It may be because a long C-type on Windows in 32 bits still. But I thought it was the opposite. Anyway. It's a good practice when you do your code that you fix the D-type. We see later. But by default, apparently, it's operating system specific. So it's just a detail for now. So we can compare the shape of the B array with the shape of the A array. And you can see that for A, we have this weird notation here, which means that it's a tuple with a single element. There is a comma sign here before closing the tuple. It's just a side effect of the Python syntax. But you can see that for A, it's a 1-dimensional array with 3 elements in the first dimension. So I don't know if some of you used MATLAB previously, but in MATLAB, by default, all the matrices will be 2Ds. And so when you have a vector, it's going to be a column of a 2D matrix. So it's a bit weird. In NumPy, it's more like an extension, a generalization of this representation when you are 1-dimensional arrays, 2-dimensional arrays, 3-dimensional arrays, 4-dimensional, as much as you want. So this is why it's very important when you have weird error messages about the dimensions of the array to always print the shape of the array that you're manipulating to understand what's happening and whether or not you are making the right assumption on the shape or not. So we can check the D-type of that guy as well. Then we can create an array of zeros. So by default, it will be floating point numbers because you have a period sign here. You can maybe insert a new line below. So to insert a new line, you can go to insert, yeah. Insert cell above or below. But it's good to know the keyboard shortcuts. So to know the keyboard shortcuts, you can go to Help and Keyboard Shortcuts. Okay. And here you will see many keyboard shortcuts. So I will just cover, introduce a few of them as we go. But if you forget about them, you can always go back to that reference, Help Keyboard Shortcuts, to remember. Okay. So here, for instance, I want to insert a new cell below. So you can make sure that you don't have the green outline around the cell. So to remove the outline, you can press the Escape key. And then you can do Control-M, B. Or even, yeah, Control-M, B. And that's insert a new cell. If you want to insert a cell above, you can click on the cell that you are interested. You click Escape, Control-M, A, above. Okay? So once you have new cells, you can type new commands. So for instance, you can type zeros, 5, and then specify the D type and do np uint 32, for instance. And you can see that this time I have an array of zeros, but those are positive integers, using a 32-bit representation. So limited to 4 billion values, approximately. All right. So there is also np.once. And here you see that we pass a shape attribute and a dtype attribute. And we execute that. We have a 2-dimensional array with 3 rows and 4 columns with ones everywhere, and those are integers. If I change here and I put float 32, I get floats instead. Yes?
When I do the shape, I see instead of 2, L, I see 2, L, 3.
Okay, so the question is, when you type shape, for instance, here, you would have 3L instead of 3. This is because you are running Python 2. And on Python 2, there is a difference between short int and long ints. So the L suffix means that it's a long, so a 64-bit int that is used to represent the shape. So it's not even the type of the data, it's the type of the descriptor, the metadata for the dimension. So it's a Windows-specific artifact under Python 2. This is why you don't see it here. But it's not, should not affect. Yeah, ignore this one and skip. All right. So now we can create arrays. So once we have some data in memory, we can do operations. So I will re-execute A, B, and C to make sure that we all get the same results. So A, B, and C. Where is C? Oh no, C is defined there. Okay. So we can define C as a new array that is the result of doing the multiply operation on the B array with a value which is 1/2, 0.5. So if we do that, if you remember, I will insert a new cell here. B is that guy. So if I multiply B by 0.5, I get C with those values. So you can see that it's dividing the values in a element-wise manner. So by default, when you do operations on NumPy arrays, there will be element-wise operation on the elements of that array. So we can check the shape of C, and if we see that C has the same shape as B, which is 2 lines and 3 columns. We can also check the D type, and this time we have a float 64 bit D type. If we check the D type of B, it's integers. So it's interesting because when we multiply an integer array by a floating point value, it automatically casts the data type for the output array into floating point values as well.
Is C a copy of B, or is it a view on top of B and B?
It's not a copy of B because if you check, if you reevaluate this line, B is still there.
But is it a view on top of B and being executed every time you use it? Or
So B has been is unchanged. So you can see that C and B have different values. So, but what it does internally is it allocates new memory for C, compute the result, and store the result in C.
so if you change B right now, C will be.
Yeah, C. We can do that.
I think C should change.
If I put a 1 in the first cell here and I redisplay B, so you can see that that cell has changed. If I just execute that, it hasn't changed. But if I re-execute the operation, then I get the C updated. So by default, when you do a multiply operation, it's allocating new memory for the result. It's also possible to, I will set B back to where it was previously. It's also possible to do in-place multiply operation using this notation. So the star equal, which means that we are going to multiply each element of B in place by this value, and we can see the result. And this is weird. It's doing integer stuff when you do in place. The semantics are wrong. Anyway, I think that could be considered a bug. Anyway, so I will just redefine B as it used to be. Okay. I reinitialize the value of B. So and here, then delete that cell. Okay. So if you recall A with those values, we have C with those values. Actually, I will reinitialize. C. Okay. And now I can do the sum of A and C. And this is weird because we are computing the sum of something that has a one-dimensional array with 3 elements. And we sum it with two-dimensional array with rows of 3 elements and columns of 2 rows of 3 columns. So what should it do, in your opinion, if we do that? Can you raise your hand? Nobody? Okay, let's do it and we'll see. So yeah, basically it applies the sum to each of the rows because it sees that the first dimension is compatible. So it does what we call a broadcast in NumPy. So implicitly, it will not do a copy of A ahead of time. It will not try to extend it. But logically, this is what it does. It tries to extend the shape of A to match the shape of C, and then do the sum. But it's smarter in the way that it does it internally because it doesn't pre-allocate the memory for A. A is left unchanged. Yes?
Is this the behavior of NumPy or is this the behavior of the language?
So the question is this the behavior of NumPy or from Python? It's just a NumPy specific attribute because in Python there is no n-dimensional arrays. In Python you can have arrays or lists, but they are one-dimensional, so there is no.
You have the freedom to implement it the way you want. You can do it in Python. In a for other equations.
But this is not n-dimensional concepts are just concepts that comes from the NumPy libraries. So we can have a look at individual elements or slices of D. So for instance, D0, I will get the first element of D, and D is basically a bunch of rows, so I get the first row. If I do D0, 0, I get the first element of the first row. So you can change and take 1 here, and you will get the second row. D of 1 is the second row. And if you take D0, 2, for instance, you will get, 0, 2, you will get the first row, third element. So it's in Python. In Python, the indexing of arrays start at 0. So it's different from Matplotlib, for instance. I think Matplotlib starts at 1. But it's a very common indexing scheme for many programming languages. So 0 means the first element. So the first row and the third column. So it's also possible to fetch all the elements of the specific column by using this marker here, the column sign, which means all the elements, and we select the first column here. So when we do that, we get a one-dimensional array with the element of the first column. So you can see here, this guy has a shape of 2 now. Just a one-dimensional array with 2 elements. Okay. Is it big enough for people in the back? To make it bigger. Okay. So we can also compute the sum of D, the mean, and we can also compute the sum of one specific axis. So for instance, if we sum over axis 0, it means that we sum over all the columns, because let me put it before to understand what's happening. Oops, no, it's D. It means we sum over the rows, so we get the same number of columns. So axis 0 is the rows. And axis 1, we sum over the columns. As we have 2 rows, we have the sum of the values matching those 2 rows. Does that make sense? Okay. Just before moving on, I would like to highlight something. So if I insert new cell, so I have D here, and I will insert a new cell where I will display, for instance, the last column, so this guy here. So we will see that this is actually a view over that array. This slicing notation here does not copy, does not allocate any memory. It's just doing a view. So it's a very efficient way to access the data without doing any memory allocation. So keep that in mind. I will show you later how it impacts the code. So let's try to create a new array, this time using a range of 12 elements. So what a range does is that it creates a sequence of integers between 0 and the total number of elements that you want. So between 0 and 11, because we want 12 numbers. We can take that one-dimensional array and reshape it into a 2-dimensional array with 3 rows and 4 columns, because 3 times 4 is equal to 12. So this will match. And we can reorganize the same data in a 2-dimensional array. Yes, you have a question?
What's the difference between a array, a range, and X range?
So the question is, what is the difference between this and that? You can do it, and you will see the result.
I think it's talking about X range. X range. Okay.
Yeah, because I'm running Python 3, I don't have X range, so, but it's the same. And if you display the result, oops, not this one. It's actually doing the same. So it's exactly the same, but this one is more efficient because it will allocate the memory for the final array. And this one will have to iterate over until the end of the iterator to just count the number of elements and store them. So it needs to allocate temporary memory and then allocate the final array with the right D type and and copy the data. So it's much more efficient when you're dealing with medium-sized data with millions of elements to use a range rather than creating intermediate data structures. Yes?
Good question. How do we get the tooltip to come up at the, if you're on the, sometimes it opens up a little help on the command there or something.
The tooltips. Okay. I think by default, if you hit tab when you're here, or the tooltip might show up after some time, but otherwise, if you hit tab, it gives you completion elements. In that case, it's not very useful. That if I start to type stuff, it does something that is like IntelliSense, but it's not as good as Visual Studio stuff. But it's using runtime information, so it's using the variables that are already loaded in the current namespace. It's not just a static analysis. All right, so let's move on to. So yeah, we have defined f as the same array as E, but with a different shape. And what is interesting is that f is actually a view over the data from E. It's not a new array. It's not allocating any new memory. And to check that, we can redisplay the content of E here. We can assign zeros to all the remaining elements. So we start at 5 and until the end. This notation means a slice between 5 and the end of the array. And we assign 0 values there. So the 5th element, the 6th element actually, until the end will be zeros. And if I do print f again, we can see that the matching entries in f have been set to 0 as well. So by default, if you don't do a copy explicitly, reshaping the data or slicing it will just be views over pre-allocated data. Yes?
Is there a way to ask f if it is a copy or a view?
So the question is there a way to ask f if it's a copy or a view, if it owns its own data, or if it is a reference to an external array? And actually, yes, you can use the flags, I think. And here in the flags, you have own data false. If I do the same for E, owns data true. So you can see that F is a view and E is the originally allocated data. So to get the relationship between the two, it's possible, but it's not public API because it's internal. E equals F. So you could do this kind of test, equality test, but you shouldn't do that on arrays. Actually, I don't understand why we get that. It might be because they don't have the same shape, so they say false by default. If you do E equals E, you have an array of Boolean that matches the shape of E. So if they have the same shape or not, you don't have the same result. So when you do equality tests between arrays, it's very important to make sure that you have the same shape between the two arrays.
When you reshape, by default it's row first, right?
When you reshape, row first, yeah.
This is row first.
Yeah, I could do 3 and 4 this way, and get.
Can you shape it, slice it this way instead
Yeah.
of this way?
And reshape in the column first. Column.
No, the notation is when you do reshape, the first element is the number of rows, the second element is the number of columns.
But he wants to pack the data this column-wise instead of row-wise.
Yeah. So the internal representation for numpy arrays by default is a C-contiguous representation. If you want to have a column-oriented internal representation, you could align the data in a different way using.
You have to transpose the separate.
You can use Fortran array, but it's basically logically it's exactly the same, but internally in memory it's the data is switched. If you want the logical transpose, it's different. You can do that. F.t or .transpose, I think that works as well. Yeah, and transpose is a view, it doesn't allocate. So if you want to transpose and allocate the data and make a copy, you can do copy. And this is a new array if we assign it to something else, like a Z, for instance. Z will be independent of F now. Oops, sorry. We assign it to a variable Z, and it's a copy. So you can call copy on any array. Actually, so we are much slower on schedule, and so people are getting in. So maybe we should open the gates for the next batch of people so that they can join. And we will go on from there, maybe a bit quickly. Do you have other questions? So maybe open the. Where is Steve or? If so. Yeah. 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 So if an array doesn't own its own data, can we make it own its own data? Basically, you just run copy and you get the result, and you will get an array with its own allocated data, own private data. Because otherwise, you just a pointer on an existing array.
So if it's a one-dimensional array, like we had E, and if I want to transpose it, looks like it still returns me. It doesn't convert rows to columns, for example, because same reason. Let's say you're slicing a matrix, then you still get an array. Just like
yes. So a one-dimensional array is a one-dimensional array. It's not a row. It's not a column. It's a one-dimensional array. So this weird stuff of row vectors and column vectors is just an artifact of Matlab. It doesn't exist in real life. Yeah. It's just a one-dimensional array. All right. All right. So, are there people getting in the room? No. Okay. So let's go on, and we will increase pace slowly. So we can combine arrays, and it's actually very important to know that in practice when you're doing machine learning. So if you have A and B and D that have the same shape, so B and D have the same shape, so 3 columns and 2 rows, and A is just a one-dimensional array with 3 elements. We can concatenate A 3 times this way, and it will still be a one-dimensional array. But we can also V-stack, vertical stack A, B, and D because they have the same number. B and D have the same number of columns, and A has the same number of elements as there are columns in the other, so it does broadcasting automatically internally. So here you see that we have A, B, and D, and you can see that integers arrays have been converted to floating point arrays because one of them was a floating point array. So whenever you do operation that mix and match integer arrays and floating point arrays, it casts automatically the results to floating point arrays. We can also do a horizontal stack of B and D, and this time it takes new columns at the end. So vertical stack is two matrices, one on top of each other, and a horizontal stack is you concatenate in the ordering of the columns in dimension. All right. So let's have a look at Matplotlib now. Hopefully you all have Matplotlib installed. So when you're running in a notebook, you can enable the integration of Matplotlib into the notebook by calling this statement, this magic function, a magic command. So it starts with % inline. And we can import the pyplot module of Matplotlib, the Matplotlib package, using the PLT alias. It's a standard notation for SciPy development, so I would recommend you to follow that also.
So, what does 123 do?
So this line here, Matplotlib inline, enables the integration of Matplotlib in IPython notebooks, which means that all the plots that we are going to do will be integrated in the notebook itself. Otherwise, Matplotlib, depending on its configuration, it can use a Qt widget, different kinds of widgets that can be external windows. Or you can also save to a file or a PDF or a PNG, depending on the backend that you select. So when we do that, it says use the image backend and integrate the image back into the notebook. So let's create an array X using the Linspace function from NumPy. So Linspace is very useful. It says we want an array with values that start at 0 and end at 2, and we want 10 elements. And we automatically find like a uniform set of intermediate point between those two values. And so we can use Matplotlib, the plot function, so plt.plot of the X value and plot that. So you can see that we have values that range between 0 and 2, and this is the integer index of each of the intermediate values. And because I use this notation like with the O hyphen sign, it means that it's drawing a line with dots in the middle. So if I change this notation and use X, you can see crosses here. And if I just put an hyphen sign, it's just a straight line, and you cannot see the points anymore. So by default, it just does line if you don't mention anything for the markers. So let's do a more interesting plot. So this time we will plot X against X. So it means that the X-axis is going to be X itself, and the Y-axis is going to be X itself. So it's the identity function. And we can plot with the same marker, and we put a label on this plot. And then we will plot X to the power of 2 against X, and put a different label. So let's execute that. So this time you can see that the X-axis starts at 0 and at 2 because it's X. And on the Y-axis, you can have the linear identity function here, or you have the quadratic parable here.
So I was looking at this. How come it turned from 0 to 9 to 0 to 2? I don't see any way all this.
Let me scale back a bit. Here, when I defined X, it's between 0 and 2 with 10 elements.
But the graph itself,
Yes.
horizontal line goes to 9, and here goes to 2. Where is it different?
So the first one was just plotting X against index,
For the first plot,
Yeah.
it's between 0 and 9. And when I just plot X here. If I do X and X, then X is the first axis, and X is the second axis here. If you just give one element, it will be the Y against integer indices. Yeah. So usually it's good to be explicit about the x-axis as well. Yes?
Yeah, you don't save this plot as a file. It's only small, save a very small, it's a very kind of bad resolution. Only,
Okay, you want to change the size of the plot.
yeah.
Export PDF.
So if you want to change the size of the plot, you can do plt figure and give a fixed size here. I think it's in inches by default for some reason. And so you can see that the size has changed. And then you can save that, save fig as some file, figure.png, and it will save it in the background. So I can try to do that on my Mac. And I have the files saved on my file system, and I can load it. Open is a Mac specific command. So just to, what you have to remember is that you can set the size with figure fixed size, and then save it to a file this way. So here I'm on Mac OS X, so it starts with a slash, but on your machine, on Windows, it would be a C column, whatever. Okay. All right. So let's work with real data, and real data is mostly random data. So we can generate some samples from the normal distribution, so a Gaussian distribution that has a mean of 1.0 and a standard deviation of 0.5, and we want to sample 1,000 elements, and we put them into an array that we call samples. We can check the shape of samples, and we have 1,000 elements in a one-dimensional array. Those are floating point values. I can have a look at the first 30 elements using this notation, column 30. If I want to skip the first 5th element, I can do that also. So 5 column 30, I just skip the beginning. If I do column 30, it's the same as 0 column 30. Okay. So now that I have this data loaded in my array, so this is Gaussian distributed data, I can call plt histogram hist. So here this notation of underscore equal something, it means that I'm storing the result of the evaluation of this function into a variable named underscore, which is a convention for I don't care. So because otherwise, if I don't do that, it will display the result before printing the plot. And for the histogram function, the text notation, it's the actual intermediate data structure that it used to build the histogram. So we don't care in that case. So here you can see the histogram, and you can change the number of bins. So if I say 10, you have like wider bins, but they are less precise. And if you say 100, you have probably too many of them, and you have like a shaking distribution because you have not many samples in your data. So finding the right number of bins when you're doing an histogram can be tricky. So I would recommend when you're doing interactive data exploration to try histograms with different values and just use your insight. There are better ways to do it, but this is the simplest way. So let's do another plot, this time with two distributions. So a first group of samples, which will also be sampled from the normal distribution with the same scale. And this time we will sample 10,000 samples. And the second is from the standard T distribution. Standard T or student T, I don't know. With 10 degrees of freedom and 10,000 samples as well. And I can do two histograms in the same IPython cell. And you can see here that I put alpha equals 0.5, which means that the opacity will be half, so that I can have the two overlapping histograms in the same cell. And here you can see the two distributions. So when you do several plots in the same figure, it's a good practice to put labels on each plot, and then to call PLT legend at the end to have some legend for the colors. So it will automatically pick up new colors each time you do a new plot. Sorry? The meaning of
Alpha.
alpha? I don't see alpha. Alpha, yes. It's the opacity level. So for instance, if I do 1 here, it's the default value. You can see that this distribution is overlapping and we cannot see the other one. So if I 0.1, it's barely visible. And so 0.5, if you have two distribution to plot, it's good. Yes, another question?
No, how do you specify we now need to have a separate different figure rather than over?
So if you want to have separate different figures, you can either do 2 cells. So for instance, if you put your cursor here, you can do Control-Shift-hyphen, I think. And if you do that, you can plot the 2 figures independently.
Okay,
So same cell,
same cell means,
plot.
yeah, same plot.
Okay. But it's also possible to, even if you are in a single cell, to call a PLT figure here, and it will recreate a new figure. And so the PLT statements that are after are generated in a different figure. So the fact that we put PLT figure here is separating the two. So this, you can see that the API of Matplotlib is stateful. It has a side effect in the background when we create figures. There is some kind of background active figure. So it's a bad design for a software to do this global variable stuff. But it's actually quite useful when you're doing interactive plotting because you don't really care about the global state. But Matplotlib also has an object-oriented API that is side effect free. So if you want to embed Matplotlib in an application, I will really recommend you to have a look at the Matplotlib object-oriented API on the documentation to avoid these side effects of using PLT figure and whatever.
Why the first figure lost the label? Sorry.
So yes.
When you had 2 figures up and down,
Yes.
and the first figure didn't have the legend and the second one. Only for the second one.
Oh yeah. So when I do that, you can see that I'm just plotting this before calling figure. So I have a label here, but there is no legend block because I haven't put that here. So if I do PLT legend before calling the figure, then I have my legend here, and I have the other one here. So I'll switch back to the original representation. Finally, when you are comparing 2 one-dimensional arrays of data points, for instance, it could be with the same number of points. It could be, for instance, the height and width of people. You can use a scatter plot to see the joint distribution of 2 variables for the same number of samples. So here, sample 1 and sample 2 are 2 arrays with the same dimension, same number of elements. It's very important. If I just if I remove the last 10 elements of the second array, minus 10, it will complain because they don't match. I have a value error because X and Y must be the same size. Okay, so it's very important when you do a scatter plot to check that. So here you can see that X is a Gaussian distributed and Y is a student T distributed. So there is a long tail of elements here. Okay, it's a detail.
Can I deal with the missing values?
So what is the question?
Can I deal with the missing values?
So the question is, can it deal with missing values? I don't know if Matplotlib support likes missing values or not. So the best way to do it is to actually put some missing values at the end of the array. So to put missing values, you can use np.nan for floating point values. It's not a number marker. And apparently it does. Oh yeah, I put missing values for all but the last 10 elements instead of. And so you can see that the opacity is really low. So I just have my 10 elements. So apparently it skips the floating point values, the missing values.
Where does these come from? Like I didn't see.
The bins? Here? The bins?
Okay.
Oh yes, when you're plotting two histograms on the same figure, it's important that they align. So if you let Matplotlib decide how to build the bins, they will be. We can do it actually. So if I say 50 and 50. Yeah, but now I have missing values. Let me generate the data again. Weird. Yeah, so it's back. it doesn't work. I think it depends on the data in that case. So whenever you're doing two histograms on the same plot, it's important to fix the bins using this Linspace. So I know that my data is going to be distributed between -3 and 3. You could use sample means, sample max if you compute the mean and max of the two distribution if you want to make sure to have all the data on the plot. And then I say I want 50 bins, and it will generate them. Why don't I did lose my data. Okay, it's fixed. All right. Okay, I think this is it for the introduction to Matplotlib and NumPy. You have other questions?
Yeah. Here, I saw the plot and using this, and we also have the ggplot. And which one do you suggest that we should plot?
Okay, so yesterday at the presentation on Python, there were a presentation of a library called ggplot in Python. ggplot is originally a library in the R programming language, but someone has ported it. It's not a port, it's a re-implementation using Matplotlib at the backend, but using the ggplot API. So ggplot is like a higher level API, so you might have less flexibility than with Matplotlib, but it's usually nicer to use. But it's a newer project, so I haven't used it much myself, so I cannot, I don't know it much. So, but it's probably better to use ggplot when you are dealing with pandas data frames instead of just NumPy arrays. And there is also the seaborn library, which is another library implemented on top of Matplotlib, which is higher level also, and it's better to when you work with data frames because it does a lot of labeling of the axes automatically for you. So when you're dealing with statistical data, ggplot and seaborn might be good alternatives to Matplotlib. There is another one which is more experimental, which is called bokeh. And this one is very nice because it's JavaScript rendering. So it works well in browsers. And it's able to display big data so that it can query the backend to just fetch a section of the data that matches your viewport, for instance. And it's more efficient to plot many samples and to do that interactively because it has a lot of JavaScript callbacks that makes it possible to have like an interactive view of the data. So bokeh, it's called this one. Bokeh plotting. It's bokeh.pydata.org. So the network is a bit slow. Yeah. So you can use ggplot, bokeh, or seaborn, but those three guys are new. newcomers. Matplotlib is like stable. It's been there for years. So everybody uses Matplotlib as the default, and if you want something more advanced, you can use those. Yes, another question?
In order for those two histograms to be put together, if two histograms use different bin definition,
Yeah.
it doesn't work.
Yes. So the question is, if we use different bins information for two histograms on the same figure, it does not work. It's weird because this is what I tried and apparently it was crashing. But I remember that it was working, but with different alignments, and so it's bad for readability. So so you have to fix the bins if you do this kind of combined histograms to compute them explicitly. All right. So let's move on to the next tutorial because we are very late on schedule. But I think it's good to not go too quickly.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.